Hey, hello there. So today is the first day for the June Leetcoding Challenge questions, and yeah, it appears that they decide to run this kind of event for at least 1 more month. So at this pace, I'm expecting to get a T-shirt by approximately towards the end of the summer. It will be practically useless at that time, but still a little bit looking forward to that. Yeah, so today's question is called invert binary tree. We have a binary tree and we want to do an inversion on that. So what does this invert mean? Question mark. Let's look at the example. We have 4, 2, 7, 1, 3, 6, 9. So the output is 4, 7, 2, 9, 6, 3, and 1. It appears that for every node we have to do the swap of the left child and the right child, and also its correspondent subtrees. And for the subtree, we also do the swapping. Looking at the example, the subtree that's starting with node 2, its left is 1, its right is 3, but after the conversion, the invert, its left becomes 3, the original right, and its right become 1, its original left. So basically, we would ask the two child to do the inversion for the subtree that's starting with them, and after they have done the conversion invert, I will swap those. So this leads to a pretty simple recursive solution to the problem. And to think about the time and space complexity, for every node we need to do the swapping, so we have to at least visit every node once. So the time complexity is order of n. For the space, it depends on the tree. So the call stack, it's trying to go as deep as possible if we do this recursion. So we ask the left subtree to do the inversion, and it would ask its right or left to do the invert, and it's just going deep. So it's depth first kind of fashion. So the time complexity, the space complexity is going to be the depth of the tree. So in the worst case, the tree can become a singly linked list, so it will be linear. So the time and space are both linear with respect to the number of nodes in the tree in the worst case. So yeah, just gonna code up the recursive one and the iterative one both for this problem. So yeah, let's code this. So I will definitely do this inversion to the both of the child, and after I ask my left and right to do the inversion, I will do a swapping. So I'm just gonna combine those in one line. Just map this function to left and right, and take the returned result to assign the left hand side result to the right, assign the right hand side result to the left. So I will do unpacking the result in the reversed order, and I just return myself up. I guess in the one more case to take care is that if the node we are looking at is it's a terminal node, its left and right are null pointers. So if we call this invert tree on the null pointers, in its recursive call, it has to return something. You shouldn't go to the second line here because the null pointer does not contain a right and left. So if it's a null pointer, it just returns itself. So that in the parent recursive call, it would just swapping the two null pointers. It doesn't hurt, and it's correct. So just gonna do this. Okay, so it's this is the recursive solution. It's pretty simple. Let's talk about the iterative version. So what we're gonna do is just do the exploration either level-wise or depth-wise. It's both fine, but if it's totally balanced the tree, I guess for the DFS search is going to be a little bit more space efficient. So yeah, so for every node, we're gonna swap the left and right and put the left and right onto the stack. So yeah, so that's pretty much it. So yeah, let's code this. Still have this here to handle the case where the root node is a null pointer. And then I'm just gonna start with a stack with the simple node here. While we still have nodes we should visit, we're gonna pop one out from the stack. And we're gonna do the right hand side and left hand side swapping. If my left hand side is not a null pointer, we're gonna push it onto the stack. We do the same for the right hand side as well. So yeah, so this is pretty much it. We got a stack. We do this, depth first kind of a fashion. So initially we just have the root node. We're looking at the left and right. We actually do a swap there. So put 769 to the left, 213 on the right, and the stack will remember to visit 2 first, then we put 2 and 7 onto the stack in this order, left and right, but we do the swapping first. So it's putting 7 on stack and then 2 on the stack. After that we pop out 2, so we deal with the right hand side there, and then swap 1 and 3 to get this 3 and 1, and put both 3 and 1 onto the stack, and just keep popping. We're dealing with the leaf node 1, it does nothing, and go back to 3, it does nothing, and then go to 7. For that, then we swap the 6 and 9 to get 9 and 6, visit 6 or 9, either one of those. I'm not sure, but yeah, it's pretty simple. So this is the iterative version using a stack. It's pretty much just mimicking this recursive call there. Yeah, so that's the question for this first day for June.